Hello, and welcome back to another episode of Today's Weather Tonight, everybody. Here, as always, I am your meteorologist for the evening, Cloud Hudson, and I will be bringing you all of tonight's top 5 stories. That's weather stories from the ground up, all the way as far as you can imagine it into the stratosphere, past the stratosphere, into the solar system, beyond the solar system, beyond the galaxy, beyond what we see with telescopes and what we can only perceive with our souls. You know, just your normal average weather report. So let's go ahead and I didn't even start up my cameras. Give me a second here. I got too eager to start broadcasting, and I didn't start my secondary camera so that I can share a screen with you. So let me go ahead and do that. While I'm getting this set up, y'all feel free in the comments to let me know what your favorite animal is or your favorite color. Just tell me something fun about you. And more than something about you, tell me something fun about the world through your eyes. What makes the world good in your eyes? What brings joy to you? I would love to know, because we all need to share that a little bit more these days. Let's see. Make sure. Usually I have a lot of windows to plug in here, and I usually do this before I start the broadcast, but I think I just got so eager to talk to you tonight. I just jumped in. Let's go for, there we go, add camera. All right, there we go. Now, let's take a look at our volcanic activity for today. Because if you're new here, what I like to do is share all of the weather with you, and that includes volcanoes. So, welcome. I see that there are people trickling in. I'm glad you're here. I usually start off with volcanoes from volcanodiscovery.com, because I love this website. They do really good work, and I also think that volcanoes could theoretically and quite literally have are proven to have an impact on large-scale systems of weather atmospherically. So it's already June 15th across the international date line, so that's why we've got these updates already trickling in from Ibu, Lewitobi, Samiru, and Popo. Let's check out our roundup for the 14th, though. Let's see, Mount Ibu still going off as it was the past few days. Same with Lewitobi, but to a lesser extent, it looks like. Volcanic activity continues, but the volcanic ash plume is not going as high as it did yesterday. Samiru in East Java, Indonesia, continues its volcanic ash emissions to flight level 150. That is 15,000 feet. And we have a great image of Dukono erupting on the morning of the 14th around 8:30 local time. And we went over that one yesterday. Here's a great image of Fuego, which is continuing its volcanic ash activity. All of them are emitting to about 150, flight level 150, except for Sabancaya has a much higher flight level that its ash is reaching flight level 250. Let's check in on what's going on in Iceland, because they haven't put a Rearcast update here in a minute. Looks like we are really quiet on the earthquakes in their peninsula there, but the eruption north of Grindavik is still going on. The eruption has lasted, as of June 13th, it had lasted for 15 days. So we are now on day 16. One crater remains active. The lava field has put out a volume of 14 million cubic meters, making it the largest. This is the largest one since December 2023, even though the last eruption that we had was one that went on longer than any of the other ones. This is the most effusive so far. The lava pond remains stable, but lava flows from it into the active lava stream north of Salingafell. Gas pollution is likely to continue in the coming days, and the hazard assessment has changed slightly. So this has been going on since May 29th. The lava pond is consistent at Salingerfell. GPS measurements indicate that land uplift in the Svartsengi area continues, and that the location of the magma accumulation zone beneath the Svartsengi is unchanged. This can suggest that magma flow from depth continues and is greater than the flow out of the crater. So remember, we get inflation in the land when the input is greater than the output. And so since we're still seeing land inflation, the output must be less than the input. So the input, the magma below the power plant area that is flowing in to recharge this inflation zone is really, really, I want to say prevalent. No, I want to say prolific. There's no clear sign of a reduction in magma flow. These are GPS uplift data measurements. So this is the movement north, the driftward east. So it is actually moving north and west because it's moving in the negative east direction. And we are having some uplift in the vertical direction, the up and down z-axis direction as well. But that's after we had a few days of subsidence. Right at the beginning of this eruption, we had some land subsidence. So that indicates that outflow is bigger than inflow. But right around the middle of the, I guess this is, it doesn't say which date this is, but I think this was about 5 or 6 days ago. Yeah, no, this is 1, 2, 3, 4, 5, 6 days ago. The rate of lava flowing out of the system, how do I say the sentence? The rate of magma flowing into the chamber under Svartsengi for the days where we had sinking was lower than the amount of lava flowing out of that system. But about 5 days ago, the amount of lava flowing out of the system reached a threshold that was lower than that which is coming in. So the curve started to go up again. Look at me. I'm just a little chart narrator. For you. I talk. If the graphs don't speak to you, I will. I can talk to you guys. This little smiley face curve, that means that for a while, we were actually deflating the magma zone. But we got to a point where the flow out decreased so much that it couldn't actually take care of that deflation. And it probably has to do with thermal gradients and flow gradients, pressure gradients, that if there was a rate of flow driven by the differential between the magma pressure and the surface pressure, then there became an equaling out, and there was no longer enough pressure behind it to drive out more than was coming in. And now we're seeing inflation again, while we still have the ongoing lava eruption, lava flow outwards. All right. I think I made that clear enough. Please comment if that doesn't make any sense. And if you're a 7th grade math teacher and you would like to have an example of what a real world situation where you'd see a parabola is, here you go. Inflows and outflows not being equal. Maybe you're a linear equations teacher in college too, and you want a fun little juicy example to do different piecewise functions, and this is a great graph for that. All right, substantial gas pollution in the last few days has been present. The gas meters located close to the Blue Lagoon and at Hafnir detected considerable gas pollution. I don't know why the Blue Lagoon is still open if they have so much gas pollution, but probably money reasons. Easterly winds last night blew the gas to the west, and the highest concentration of SO2 was measured over 8,000 micrograms per cubic meter. Gas pollution can be expected to persist for the next few days. Easterly winds continue today. Let's see. And that means that the easterly winds means that the gas will travel to the west, which the Svartsengi area and the Blue Lagoon area are just right due west of where the eruption is. So when there are easterly winds over the area, the winds are going to blow the eruptive gases right into the Blue Lagoon. So unfortunately, this is the eruptive crater. This is Salingafell, where they said that the lava is pooling, and you can see that pretty well. It's snaking around the edge of Salingafell into the area where we've got some obstruction walls, some walls to keep back the flow. But unfortunately, I mean, look at that. You can see it on the elevation map. You can see where they've built these damming walls to keep the lava flow out of the area. Thankfully, they haven't gotten any lava flow over these red lines right here, which are the hot water pipes that go to the local cities. I mean, they go out that way and that way too. And the one at Grindavik has already been destroyed. Grindavik's still under a red level, threat level. That's zone 4. Sinkholes, fault movement, gas pollution, and lava flow is a risk. I don't understand how they don't have zone 1 in that same warning level, because obviously we're seeing that the gas and lava are making their way into there. But I guess they figure that this area is safe because they need it to be safe. And if it's not safe, that would suck. So let's just make a map where it looks safe. I don't know. Okay. Here's a great aerial shot of that actively erupting crater as well. You don't really see as much iridescent, incandescent, like heat light from that, but it's there. Let's see. Let's look at the gas pollution. Oh, increased chance of landslides and or rockfalls in the northern part of the country due to thaw and melting. There have been a lot of rock and landslides recently in the headlines. I think that is, we might be at that point in the year where a lot, I mean, it could be Mars in Taurus co-present with Uranus, but it also could be just that we're at the melting point of the year. Let's look at our gas forecast. Okay, it's looking like it's going offshore right now. But if we look back, oh yeah, if we look back even 6-7 hours today or yesterday, Friday, this is today, Friday, this was just hovering over everything. So that's really nasty. Let's see if that shows up on our, I wonder if any sulfur, if any sulfates are, because this is sulfur dioxide. I wonder if any sulfates are showing up in Iceland. We're going to look at null Earth to see that. And you can see they're barely out of the westerly zone. Or the easterly zone. Let's see, particulates. So I think the sulfur dioxide would show up in particulate matter under 1 or 2.5 micrometers. It's not really showing up. But let's look at sulfate extinction. Yeah, and that is actually showing up for today. And remember, there's different weather conditions will create different gases when lava is exposed to the open air. Different chemical processes go on when there's different composition of the atmosphere. Different. Can I use a different fucking word? I know. Yeah, I'll think of another word soon, eventually. But again, you also see lots of sulfate coming off of areas where they've got natural burns going on, processes that, like industrial processes that can off-put this. This is a typical type of pollution. There's also, we could look at organic aerosols. Let's look at dust extinction while we're here. Man, still capping off that tropical Atlantic zone with tons of Saharan wind. Saharan dust. There's been a lot of rain in the equatorial Africa countries, but especially in coastal West Africa, but there has not been a good amount of we're just really lacking hurricane forming conditions out here. Anyway, I will get to that in a moment. We'll get back to this in a moment. Oh, while we're talking about mudslides and rock slides, here's one of them. There was a landslide in the Himalayas in a region of the border region of India and Nepal, where heavy rainfall on Thursday left 2,400 tourists stranded in the northeastern Indian state of Sikkim. 6 people unfortunately lost their lives, and another 4 died from the landslide in neighboring Nepal's Koshi province. It's been raining continuously for the past 36 hours. That is just devastating. Take a look at that mountainous terrain just crumbling, melting. It's like, I mean, this is when I really think of the earth like a cake. Like, that is just a hand just sweeping through and melting it. Or like maybe it's a sculpture made of sugar, and you can picture it as being melted by somebody pouring water on it. Either way, it's really important to remember that even solid earth can and is in motion, can be and is always in motion. And it's always in motion on a long time scale and can be in motion on a short time scale as well, depending on atmospheric conditions. West Bengal dealing with these floods and landslides, the mudslides. It's really torrential rains. This has been a record long summer, though, with parts of the capital, Delhi, reaching up to 121.8 degrees Fahrenheit last month. Yeah, this has been a very challenging climate, a very challenging summer for India, especially northern India. But we're going to get to that. We're going to get to checking out. I mean, finally, it doesn't look quite as hot as it has been there. We're only at 103. We're only at 103, 107, 105 in the Uttar Pradesh province, but we are still looking at nasty, nasty heat And let's take a look at the rainfall. Wait, do I have that on this one? I don't think I have a good view of rainfall on this one. We're going to have to look at the global flood map for that. And I did actually go ahead and register for the Copernicus global flood map view. That is one that I do need to cite as accessed on June 14th, 2024 by me. This is the European Union's Copernicus global flood awareness system forecasting. This is the area where all of that nasty flooding has been, and right here in the border region of Nepal and India. And then there's also upcoming, the red and pink here is our precipitation probability that will be greater than 300 millimeters. So that is a lot of rain, and the red, pink, and purple little line segments, that's where we see flood summaries coded by this key right here. 2-year, 5-year, and 20-year exceedance of averages probabilities. So purple being most severe, yellow being least severe, but definitely present flooding throughout the region. And I pulled this up because I was looking for a good map of Chile's current flooding. Chile has been hit by heavy rains. There's apparently a state of catastrophe declared. Thousands have been displaced and lost power. It's been called a disaster zone. Central and southern regions of Chile have seen torrential downpours. A lot, again, days and days of rain in a row, just not having anywhere else to go. So that is why I pulled up the Copernicus, so that we could really see. The squares here are my observed flooding extent. Red squares being flooding detected, unusually high amount of flooded area, and green being flooding detected but not unusually high amount. So the red areas overlapping here in these areas of Chile are where we're looking at like really, really impressive rainfall. And that's not even the only region that there's unprecedented rainfall. There's a lot of rainfall here in Argentina as well. And I think more is coming to all of these areas. But this is a pretty nice mapping system. I think I'm going to start using it on the broadcast more. I don't know why we don't have anything here in the Alps boxed as in flood stages, but I mean, we do have it kind of close to Budapest. I think you're supposed to say it with the SH sound. It's not Budapest, it's Budapest, maybe. Anyway, you can also really see the Austrian flooding that we were talking about a few days ago here in southern Austria. This is a really clear example of where we are exceeding our 20-year averages. Also, northern Russia near the Pechora Sea. This is a great mapping tool for visualizing floodwaters, and I think I'm going to continue to use this in our updates because this is showing a lot of good information. Also showing an interesting overlap in where we're getting a lot of flooding with where we are seeing the concentration of earthquakes. So with that, let's go ahead and take a look at our earthquakes. Just look at Central America and southern Mexico, just absolutely inundated with flooding and very, very heavy rain. Though heavy rain doesn't necessarily mean flooding there, because that is part of the climate, the typical climate. And let's look at Florida. So if we are putting in comparison what these averages, these comparison to 5 and 20-year averages are like. What we're experiencing here in southern Florida is registering similar to what they are seeing in central Chile, northern Russia, and southern Austria, as well as in parts of Nepal. But there's, it takes less flooding to make a landslide in the big, very steep mountains. Also looking at flooding up in or increased rainfall really in Alaska, which again, I'm going to go to look at our earthquakes because it looks like a lot of these flooding areas are similar to where we see our earthquakes. But let me check. Hello. There's a ton of landslides here. Where is here? Kaylee C. I forget where everybody says that they're from. I know that I have viewers in handfuls of places, but I don't remember which places are which go with which people. Okay. And Cushy Kale is in NorCal. Let's see. Well, let's start our update there then. California, hard to pick out what's a big quake, so let's go to like slightly over 2s. Our most recent quake that came up was this 2.4 at 6 kilometers depth here in West Texas, but we've also got 2.6s all throughout South Central California. And then up towards NorCal, we had 2.3, and then off the coast at 2.9. We also had a 2.2 here in where I'm going to turn on borders. I always say borders are fake, but let's they're useful sometimes for knowing which part you're talking about. 2.2 here on the Idaho-Wyoming border, and that is unfortunate because there is a lot of. I read an article yesterday about how the collapse of a stretch of Highway 33, I believe it is, has stranded workers who work in the really, really rich billionaire part of Jackson, Wyoming, but have to live in Idaho because they can't afford to live in Wyoming. There are people already commuting like hours per day over this state line. And now that part of that road is washed out, people are having to commute like 3 to 6 hours extra per day. And this is all because the billionaires that live in Jackson aren't opening their doors to let people shelter in place so that they can work in the hospitals and the restaurants. But I digress. It would really suck if there were more road closures out there. It just highlights economic disparities. But yeah, NorCal looking like we've got a 2.3 right off the coast. And that ricocheted from, well, that kind of coincided with where we had this 2.4. They were both pretty recent ones, this 2.3 and that 2.4. And then earlier in the day, we saw these 2.8, 2.6, and 2.3s. Then, of course, there are a ton of tremor-sized quakes scattered throughout the area. Both in the Pacific Northwest, Washington, Oregon border region, and I wonder where this is. Where is that? The geysers, of course. Near the geysers, California, tons of little quakes. That is right in line with where this 2.3, 2.1 came in, and then headed to the 2.8 area. At Milpitas near San Jose, California, near the Bay Area. So right on that San Andreas Fault line. The earthquakes just keep going down that San Andreas Fault until they get to Southern California, where they're really popping up all over the place, both on the fault line and up into the hills into the Mojave Desert and the are these the Sierra Mountains? Which mountains are these? It's the Mojave, the Death Valley. Oh yeah, the Sierras, the Sierra Nevada mountains. Duh. All in the Sierra Nevada mountains, and kind of skipping the San Joaquin Valley and going straight for the LA basin. Let's see. There's all kinds of stuff out there that I will let other YouTube channels talk about because I don't know too much about it. There's all kinds of stuff out there that determines the shape of how these earthquakes move underground. But yeah, we're seeing a lot of activity there. We also saw more activity in Oklahoma than we have been seeing, and quite a handful of 2 and greater magnitude earthquakes in West Texas, not New Mexico, definitely West Texas. Then as we go down into Mexico, where I was talking about getting all that rain coincident with like 3.9 at 109 kilometers depth, 3.7 only at 25, 3.6 at 77, 20, and 14 kilometers. So these are really staggered as you go down the coast, this Pacific coast of Mexico. There, the depths really stagger. But then we get into this stack here near the border, or very close to the border. We get 4.2 far down. Let's see, what is the furthest one down we can get? 4.2. The 3.8 was at 101 kilometers depth. I think these are all reading mid-range depths in the like 20 to 40 kilometer deep range, but there is a 101 kilometer depth earthquake there. And then the regular stack of earthquakes that we've been seeing in Puerto Rico are ranging from a 1.7 all the way up to a 2.6, mostly centered around 2.5 size, and they're in the 5 to 10 kilometer range. We have 5.0 here in Peru at 10 kilometers depth. I think maybe we went over that one yesterday. 4.5 here in Bolivia at 191 kilometers depth. And here, exactly in the area where there is flooding in Chile, we see a 4.7 at 28 kilometers depth. So, again, seeing earthquakes at the places where there are floods. Speaking of which, let's take these quake ring sizes down so you can see that southern area of Alaska that was flooding is also undergoing lots of quaking, as is the northern area where we had a lot of flooding. Oh, wait, I never changed did I change this on your screen? Oh, I did. Oh, gosh, I thought that I can't feel those, can we? I don't know. I have never felt a quake. I've experienced them. I've been in places that had quakes and never felt them myself. But, so I don't really know what you would be able to feel. Okay. Where did Kaylee go? Kaylee C, come back. I only see one viewer. I want to know where you're seeing landslides. Okay. We've got another 3.5 out here on like the Alaska Peninsula transition into Aleutian Island chain area. We also had some more surface quakes up here in northern Alaska. And wait, that's an old 4.2, isn't it? No, a new 4.2 up here in very, very far northern Canada. That would be a 4.2 at 9 kilometers depth here in Inuvik, Canada. So that's an exciting one. Let's see. Next, we have we had a 4.0 out here in Hawaii. That's been a while since we had a 4.0. We had a 4.0 at 36 kilometers depth. Let's see. What other size quakes did we have out there? 4.0, 2.5. Where'd my little... There we go. Come back here. 4.0, 2.5, and 2.7. The 2.7 was at 0 kilometers depth, and the 4.0 and 2.5 were just offshore. Their epicenters located just offshore. Then let's take a look now. Back on the Kuril Islands, we had a 4.3 and a 4.1, both around 39 kilometers depth. A 4.9 near the Bezmiany Kamchatka Peninsula of Russia, right where it meets the Aleutian Island chain. And we're continuing to see earthquakes ripple through the diamond-shaped plate boundary formed by, a deep one, a 4.0 at 427 kilometers depth here on the undersea ridge that you see being pushed up by the Pacific plate subsiding at the Marianas Trench area. Then we have a 4.3 at 57 kilometers depth in the Volcano Islands of Japan, and a 4.4 smack dab here between Taiwan and the Philippines at 10 kilometers depth. Let's see. We had a few as we go through the Philippines, climbing deeper into the 99 and 170 kilometers depth region. Some shallower fours as we go into Indonesia. Then we go back to our favorite wave-shaped plate boundary, of 4.8 at 147 kilometers depth. A 4.2 at 559 kilometers depth. That's almost 600 kilometers depth. And then here in Tonga, we had a 4. The Tonga was the one that was at 139. 4.2 was at... No, that was at Tonga. No, it was at Fiji. The 4.9 at almost 600 kilometers depth was in Fiji. And then 520 kilometer depth, 4.4, as we climb down there southward, headed towards the Kermadec Islands and New Zealand. Ooh, we have 3 new quakes here on the Antarctic Australian plate boundary, all at 10 kilometers depth, all about mid-range 4s. We also had a 3.3 surface quake. Surface 3.3, I feel like you should be able to feel, but that's a relatively unpopulated area of Australia. And a surface 2.5 as well. Then as we got into the string of islands that lead us into Indonesia, we had these cluster of mid-range 4s, a 5.2 and a 4.9 here just south of Sumatra. That would be... Wait, is that Sumatra or is that Java? But As I was, I'm not on stream anymore. I disapply. I disapply. I disappear. Okay, that's you. Oh, landslides in Humboldt County. I haven't seen any news reports of that, so you heard it here first, folks. Let's see. Okay. There we go. Here I am. So today, lots of activity out in the Central Plains and the Panhandle of Texas. Let's load up our 250 frames and see what it gives us. Both for flash flood warnings. Areas, New Mexico and Colorado are getting a decent amount of rain for the desert late, and I think they would be in flood conditions on that flood map that I showed earlier as well. Okay, let's load. Let's go. I want to see this. I want to see this blow up. I want to see this storm explode. Let's go to 50 frames. Maybe it'll be less persnickety. Sorry, I keep yawning. All right, I'm going to try to close Earthquake 3D and see if that makes my Radar Omega load faster. And it did. There we go. Oh, that is an interesting southwest to northeast movement. Really interesting. I mean, it looks like it's really swirling around North Platte, Nebraska there. Got a severe thunderstorm warning for 60-mile-per-hour winds and 0.75-inch hail. But then also some special weather statements looking at winds up to 50 miles per hour, gusty conditions. You can see there are some pretty strong reflectivity signatures with this as well. Doesn't look like while the line is breaking down, and this looks like it's trying to rotate, honestly. Look at that. Look at that. It looks like this wing is trying to curl up in the background. I don't think it has tornado potential, but it's just very interesting to see it like lapping back on itself as if it's like an eddy created through vortex shedding. That's a really interesting pattern of, I mean, you don't usually see it move that way. I mean, it's not unheard of. But this is also part of the same system that down here from Roswell to Amarillo is creating quite the cluster of severe thunderstorms. And these are really, I mean, look at that ring shape. That's really weird. It's like a big old bean. A big old bean. A big hollow bean of clouds are being formed to the northeast of Roswell, New Mexico, headed up into the Panhandle of Texas, where they then kind of coalesce into a more or less normal looking system. But it does kind of look like two streams twirling together. That's just my visual inspection opinion of what it looks like. Not making any conclusions. You draw your own conclusions. Up here in Seattle, we do have a flash flood watch. We are looking at flash flood watch expiring in 3 hours for the Bolt Creek burn scar. Burn scars are notorious for flooding more easily because there's not as much vegetation to be able to hold the water in place. Less complex soil structure means a harder time absorbing the rainfall. Looking at flash flooding and possible debris flows in Bolt's in the burn scar of Bolt Creek. Let's see. No warnings issued for Humboldt County. However, I believe that let's take a look at our local radar here because there's probably some anomalies getting let's look right here. Probably some anomalies getting wiped out of our mosaic. Yeah, you see how as the cold front moves onshore, there's an interaction between the different peaks and where rain will show up. If you're raining just on the top of the mountain, yeah, of course you're going to end up with some mudslides and flooding because it just hangs out in the same exact area because of adiabatic lift, because of the way that water condenses out of an air parcel as it flows up the side of a mountain when it's forced to go over a mountain by the wind direction. The rain just continues to be created and fall in one spot. So I can definitely see how there would be some mudslides and flash flooding in your area down there, Kale. Let's see. Portland radar. Again, looks really looks rainier the closer you get to Rainier. Closer to Mount Rainier, the rainier it gets. And you see these seaside clouds coming into view of the radar. That is not what's going to create the most rain in this area. It's really going to be what I was talking about, that elevation driven precipitation in this area. That's going to be pretty substantial. Like here in Weed, California, or near Mount Shasta, that's just going to be rain hanging out in one spot because these are clouds clinging to the top of mountains and not necessarily precipitating, but definitely with the potential to rain because they are creating precipitation. While we're on single site radar, let's take a look at what this looks like on single site from North Platte, Nebraska. Interesting, really interesting thin segments coming together. A lot of little radar anomalies poking out there too. Yeah, you see this like wanting to wrap itself up right here? There's some sort of weird... If this was this, so this is a fluid. If we could imagine this in 3 dimensions, it's got to be... Actually, I probably can put it in 3D. Hold on. Let's see if it will let me. Okay. So volumetric 3D is one of my favorite ways to view storms. We're going to see concentric circles around the radar station. That just kind of shows you basic clouds, but it won't let me click through. But oh, it won't let me play in volumetric. But yeah, this is what it looks like around the radar station. Don't really get to see it in action, though. That's a really interesting shape storm. I wish it would probably look like, if you got to see it in 3 dimensions, it would probably look like a drop of fluid expanding throughout another fluid. Another special weather statement looks like we're up to 50 to 55 miles per hour warnings for near Franklin, Minden, and Kennesaw or Kennesaw or Kearney, Nebraska, south central Nebraska, looking at getting a bigger sweep of severe thunderstorms out of this. Really just blowing up over Norton overnight. Let's see what the mesoscale discussion has said about this. Man, it looks nasty. Strong mesoscale convective system activity ejecting east out across central plains involving will go into the overnight hours. The air mass downstream of overall areas of central and northern Kansas and nosing into areas of south central Nebraska is quite unstable, with mixed layer CAPE values of 2,500 to 3,500 joules per kilogram. This is in part being strongly influenced by the gradual arrival of shortwave energy over the high plains associated with upper level trough crossing through the central and southern Rockies. This forcing should help continue sustain the ongoing convective mass, and especially over north central Kansas and south to southwestern to south central Nebraska. Okay. Moist convergent low level east southeast flow and the aforementioned instability aloft pooled over the region will be a key factor in supporting rather high rainfall rates, up to 2 inches per hour. Some storm totals 3 to 4 inches, with isolated heavier amounts possible. Guidance shows some 20 to 30% probabilities of 3-hour is FFG. I don't know what that is. Exceedance going through 6Z. Oh, flash flooding. 3-hour flash flooding exceedance going over 6Z. Probably going to last into the overnight hours. So yeah, definitely this is not going away. This is here to stay overnight. Some really nasty, heavy rainfall. Hold on to your hats. At least it's not moving in the direction of propagation, or it's not shaped of the direction of propagation. It's like moving pretty perpendicular to its shape orientation, which means at least it'll move through the area pretty fast, except for in these areas where it's moving side to side. This area actually probably got a lot of rain. But it's moving, it's sweeping through, and it's definitely doing that rolling rotation that I'm always talking about, the swirly puffy Cheeto, the rotating, like a crashing wave, roll cloud, vortex shape. It's doing that. And that reaches back into Colorado as well as Panhandle of Texas, Clovis, New Mexico, very far eastern New Mexico. So that is where we're at there. Let's see. Let's go back to our global flood awareness system. Yeah, looking at flooding possibilities in exactly those areas we talked about. They don't exactly have this area highlighted as it should be, but let me turn on Yeah. When I turn on precipitation probability over 150 millimeters and 50 millimeters, then we get a much better view of what's actually happening with the global rainfall rates. Interesting texture there as we get into South America. And yeah, they're the areas that are already flooding are expected to get more and more rain. So, except for in Europe, I think Europe things are going to cool off just a little bit, but definitely in Himalayan India and Nepal, there's going to continue to be flooding. Definitely in southern Mexico and central United States, as well as south central Chile, there's going to continue to be a lot of rain and flooding. That is at the same time that we are monitoring drought globally. Let's see if they don't have a drought monitor on here. I'm sure I can figure out how to get a drought monitor on here. But anyway, let's see if our misery index shows. Yeah. Not too favorable. Not too awesome. Not too bad either. Not as bad as it has been, but not that great. All right. From the atmosphere, let's go to talk about our weather headlines. We've got a massive dead zone forming in the Gulf of Mexico. That is typical. However, this year's is going to be pretty large, 600 square miles larger than average, though it's not predicted yet to be as large as the one we had in 2017. That is when we really peaked for terrible, terrible agricultural runoff into the Gulf of Mexico. I think that I really do think that agricultural practices are changing and people are learning that it's just not going to turn a profit to use traditional types of farming anymore. That the USDA is behind the times and that having to purchase your nutrients is not a good business model for farmers. And adding nutrients rather than establishing a healthy soil ecosystem is a bad thing. So I hope that maybe our dissolved oxygen levels, these dead zones, these areas of very low dissolved oxygen levels, will become a thing of the past in the future. But currently, while we still have so much agricultural usage of the land in traditional agricultural type settings, we're probably going to continue to see these kinds of things as an annual occurrence. We are also about to get into a large heat wave. While there has been a heat wave in the western United States, we are about to get into 90s all over the eastern United States. It's funny, I was just looking at the pivotal weather map of this yesterday on stream. A record-setting heat dome is a ridge of high pressure that brings hot, dry, sinking air. That squashes any cloud cover. It also shunts the jet stream to the north, meaning rain and storms are hard to come by. Weather models are already bullish on the magnitude of the heat dome. Heat domes expand the air vertically because warm air expands. That's funny. That's great. That means halfway point of the lower atmosphere's mass bulges upward. Think of every column of air as its own balloon. If you heat the balloon, it will grow. The halfway point is the 500 millibar level, of course. And that pressure level may reach a key threshold next week, 600 decameters, which is 6,000 meters. 500 millibar level has seldom, if ever, climbed above 600 decameters anywhere east of Ohio. Some weather models indicate that it could happen by next week, even if it doesn't, the heat dome will still be really bad. We're looking, I know Californians are used to heat waves, but this is an area of the country where people don't have air conditioning and have not had air conditioning for since it was invented. Like the Appalachians specifically, this is an area that stays so cool that you don't usually think you need AC to survive. It's thought of as like a luxury. So this kind of heating over these areas is definitely going to cause problems. People won't know what to do with this amount of heat. It's going to be, we're definitely going to see some headlines about people not dealing with this heat very well. And as we know, heat also drives up crime. I don't want to be negative and scary about it, but like people make more rash decisions when they are more uncomfortable, especially if they are experiencing life-threatening heat waves. People get very drastic very fast. I think it's no shock that a lot of rebellions happen in the summertime because hot weather makes people testy. So let's try to stay cool literally and physically next week in the East Coast. Let's try to just keep simmer down, keep a lid on things. Let's not freak out. Everybody stay calm, okay? Because this is a bad forecast if you are trying to avoid unrest. It's also a bad forecast if you want people to survive, because people are not going to be able to survive this. It's going to happen. I don't want there to be deaths, but there will unfortunately be deaths from this heat wave because people just aren't equipped for this. We don't have the infrastructure to keep people cool enough here. And there's definitely not enough public will to keep people alive. I can tell you that. And if anything, the attitude of a local government would definitely be one of hemming and hawing while people die instead of doing something. But prove me wrong. Local governments, prove me wrong. If you think that you can keep people alive during a heat wave, why can't you keep people alive during freezing temperatures? I don't know. Probably just going to toss anybody who's already outside to the coals. Oh, to the internet. Oh, I wonder why. About that. Okay, there we go. Okay, we saw more of these discrete vertical power bursts, in addition to more of a quieting down of our upper modes. But mode 5 is still peeking out there, definitely showing up all 5 modes. Let's look at our power levels. See where that went. Yeah, several discrete bursts of energy coming in. One of them really led by mode 2, the most recent one led by mode 2. That's quite interesting. About the same amount of power going into mode 1 as mode 2. And then this mode 4 led one on the 13th was quite interesting. We've gotten a lot of mode 4 power downloaded recently. Let's see what that did to our frequencies. Frequencies are up, man. All of the time between these power bursts has given the frequencies time to raise back up there. Mode 4 might still be a little low, but mode 1 and 2 are sitting pretty healthily. Mode 3 and 4 are definitely on their lower ends, but they're higher than the average of this graph. So let's see. From here, we like to take a look at the space weather. Let's see, quite a few coronal mass ejections today from 8. Let's see. Let's pick a random one and see if we can see the video of it. That's pretty. And you can also see Mercury moving into its superior conjunction. Let's see the previous one. A little baby one. The next one. Not many doozies. Not many doozies here. That one looked the most exciting because right here, that looks the most exciting out of any of these difference images. But it doesn't even last that long. Very, very concentrated angle and speed distribution there. So we had 8 coronal mass ejections today. Let's see our solar flares. Solar flares, we did have another M-class flare last night, probably around the time I was broadcasting, right after. And we didn't really reach M-class flare since then. So we had 1 M-class flare today. That was from region 3712. That's the one that we've been keeping an eye on since it showed up on the Earth-facing disk. And yes, it is now a beta gamma delta type. Didn't I say that yesterday? I said it went from a beta to a beta gamma. I bet tomorrow it's going to be a beta gamma delta. And look at that progression. That is gorgeous growth from this this sunspot region. Let's take a look at the sunspot region itself. Yeah. Oh, man, that is really blown up. And 3713 is now a beta gamma type. So let's see. Yeah, 3712. Take a look at those deep, rich blues and reds, meaning that there are really strong polarity magnitudes of the magnetic field there. They're also showing up very dark on the intensity gram. And you can see what a complex web of magnetic flux lines have been woven here. I can't wait to see what this one does. Really, I think this is just getting started. 80% chance of C-class flares, which it has already been doing. 5% chance of X flares. I hope it gets bigger. This is 3713, and it is now a beta gamma type. And I see the beta and the gamma. It's still not too complex, but it's definitely growing, and definitely growing in intensity. Right here, you see that really intense polarity showing up. Let's see if we can see any of this with field lines. I'm going to look at magnetogram with field lines. Yeah. That is what all the complex nastiness is giving us. It's giving a lot. I mean, even 3713 has a lot of complexity to it, but they are connected through some field lines, as well as being connected to other sunspot regions. And then this big coronal hole in the middle, that's areas of open magnetic field lines where they're not closed into a circuit on the sun's surface itself. It's going out between, the sun and us. So as those face us, as those coronal holes face us, we get fast solar wind because there's higher coupling between the sun and the earth. Let's see. What video do I want to watch? I feel like this is going to show a good growth of the sunspot regions today. Yeah. Watch these things balloon up with their lightning spurting out. Just really bulging, growing like a slowly boiling pot of pasta on the stove, where you can see that I think of it as pasta water because it sticks around and foams up like that pasta water with the nice starches in it. Beautiful. That's going to be a real contender, I think. Not to ignore the other sunspot regions, because those would be exciting themselves in a solar minimum. Let's see. M flare, radio blackout R1. Not too much else going on. Hemispheric power is way up, though. I think that has to do with our facing a coronal hole. KP index is also up to like a 2.5, 2 plus. So that is good for you Aurora fans, but the moon phase is in a waxing first quarter. So we're probably not very good for Aurora viewing. Looks like there's very little chance of viewing Aurora most places in the world right now. But we do have good coupling between the interplanetary magnetic field and us. So let's see what that means for the magnetosphere. Probably should have done atmosphere, magnetosphere, then heliosphere, but I didn't. I forgot. Yeah, look at that higher velocity. Let's check this out. And the little echo reversing of wind speed direction in the magnetotail of the Earth goes back into the Earth sphere as well. Not many new waves of wind, but definitely you see the moire patterns, those interference patterns of the lines of Earth's radiation belt swirling around, rotating around. It's very easy to see. Part of that is natural and part of that is man-induced, but not like nefariously, just by like actually putting satellites into space and communicating with like GPS and stuff. Look at our density. Density seems like the less exciting one to me, unless there is a new storm coming in. So I don't always take a look at it. This is the one that looks the most like a contact lens to me, like you're looking at somebody's eyeball. And it also really shows the orientation of the Earth's magnetic field, both in the vertical and side to side. Like you can see the tilt of the Earth's axis because of this line right here. This horizontal shows the tilt of the Earth's axis, and this shows the rotation of the poles there. Let's look at our pressure. Looks like we have a little bit higher pressure in the magnetosphere right now. I really wish their color grading went up higher, but these might just be models that max out there. I mean, they're models for sure, but really interesting. Nanopascals, at least 1.5 nanopascals. And in the wake of the magnetosphere, the wake of the Earth's magnetic sphere, we're seeing a big charge, a very high pressure reading back there. Or prediction, not a reading, because it's not an observation. Really interesting that it kind of sloshed everything from forward to backward. That's probably what's really helping. That's probably driven by and helped by a lot of that magnetotail backwards wind. All right, next, let's go to our current planets, planetary weather. All right. It is a Venus day. We started this broadcast during a Venus hour, and it is currently a Mercury hour. So, Friday, Freya's day, Venus day. Let's talk about Venus. She is sitting pretty at 27 degrees of Gemini. making a square to Black Moon Lilith and a square also to Neptune in Pisces, in the last degree of Pisces. She'll be in the last degree of Gemini soon, so that'll be a really ultimate moment. That is also making a slight T-square. We've also got a bit of a grand air trine formed today with our moon in Libra at 5 degrees Libra, trine Pluto in Aquarius at 1 degree, trine to Jupiter in Gemini at 4 degrees. So air, swords, intellect, words, law, spirit made physical, made manifest in the world. Gemini bringing us the stellium heat, the big grand expansiveness of Jupiter in Gemini. We also have the seriousness and long-standing goals, vision, legacy building of Aquarius, matched with the death, rebirth, beginning, endings, finalities, power dynamics planet of Pluto. And we've also got Moon, the physical body, the emotions, the instinct, the subconscious, the physically known knowledge in Libra, the diplomat, the justice oriented, beautiful, graceful, popular social butterfly, socially in command sign. So that is a great sign. Yeah, I think that's really all I want to talk about today with that. We did just have the moon conjunct, the moon before it passed into Libra conjoined Black Moon Lilith, which is its apogee point, which is its furthest physical distance it gets from the Earth during its rotation around the Earth. So the moon is pretty far out there right now. So it can probably catch the beams of Jupiter and Pluto, these massively far away and massively huge planets, to bring the energy of those planets into aspect with the Earth right now. Really interesting. Okay, so from there, I would like to go on to, I want to do a reading from the liminal space today, because I did one from only the tarot yesterday, and I'm feeling like liminal space will treat better today. Not better than yesterday. I just feel like liminal space is the choice for today. All right. Oh, and we got snake medicine again. I got this one the other day. Guess that is the energy coming through from the universe quite strongly right now. I swear every single card is different. I just, sometimes themes recirculate and they don't stop showing up until the lesson is learned or taken or integrated. So out of 50 cards, we'll still see the same ones pop up, because there is something more chaotic about getting the same cards over and over again than if we just drew different cards every time. There's something less probable about that proves the significance that I think this deck likes to show us. Okay, snake medicine. The alchemy by which the poison may be used as the remedy, creating the immunity necessary to effectively navigate safely inside otherwise poisoned ecosystems. Life will adapt to and evolve from even the most toxic and polluted environments. So that is a bit of bright news in comparison to what I brought up about the hypoxic ocean dead zones forming in the Gulf of Mexico. There are always, life finds a way. Might go watch Jurassic Park tonight or something, because life do be finding a way. There's something about your toxic side, your nasty side, that your shadow side that you don't want to look at, that has something to teach you right now. So maybe examine it. Hold some space for your nastiness and figure out what that's for. All right. I'm going to go do some reflection on that myself. So I love you guys. Thanks for coming to another episode of Today's Weather Tonight, and have a good evening. Bye.